Namaskara. In this video, we are going to learn how to derive an expression for electric field due to a uniformly charged spherical shell. So, basics as usual. What are the basics required for us are, first thing, shell. Shell means which is hollow inside. Okay, ಒಳಗಡೆ hollow ಇರ್ತದೆ ಅದನ್ನು ನಾವು shell ಅಂತ ಕರಿತೀವಿ. The surface area of the shell is given by 4 pi r square if r is the radius. And next thing is we should know the Gauss theorem. Gauss theorem ಏನು ಹೇಳುತ್ತಂದ್ರೆ summation of vector E dot ds or delta s is equal to q by epsilon naught, which is nothing but flux enclosed by a surface, what we call it as Gaussian surface ಅಂತ ಕರಿತೀವಲ್ಲ, ಅದರ ಒಳಗಡೆ ಎಷ್ಟು ಚಾರ್ಜ್ ಎನ್ಕ್ಲೋಸ್ ಆಗಿದ್ರೆ ಅಷ್ಟು ಡಿವೈಡೆಡ್ ಬೈ ಕ್ಯೂ ಬೈ ಎಪ್ಸಿಲ್ ನಾಟ್ ಮಾಡಿದ್ರೆ, ಚಾರ್ಜ್ ಡಿವೈಡೆಡ್ ಬೈ ಎಪ್ಸಿಲ್ ನಾಟ್ ಮಾಡಿದ್ರೆ ವಿಲ್ ಗೆಟ್ ದ ಫ್ಲಕ್ಸ್. ಯೂಸಿಂಗ್ ದ ಫ್ಲಕ್ಸ್ ವಿ ಕ್ಯಾನ್ ಆಲ್ಸೋ ಕ್ಯಾಲ್ಕುಲೇಟ್ ದ ಫೀಲ್ಡ್. ಸೊ ಯೂಸಿಂಗ್ ದೀಸ್ ಟು ಪ್ರಿನ್ಸಿಪಲ್ಸ್ ನಾವು ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು derive an expression for electric field due to a spherical shell, first region outside, second region on the surface and ಮೂರನೇ region inside the sphere. ಈ ಮೂರು ಕೇಸಸ್ ಮಾಡೋಣ. ಇಂಪಾರ್ಟೆಂಟ್ 5 mark question. The probability of asking this question is very high. ಭಾಳ ಸಲ ಕೇಳಿದ್ದಾರೆ PU ಬೋರ್ಡ್ ಅವರು. Okay. So for that, let us consider a spherical shell of radius capital R. Okay, which is carrying a charge plus Q. Okay, total charge ಇದರ ಮೇಲೆ uniformly distribute ಆಗಿರುತ್ತೆ because it is a conductor. So ಇಲ್ಲಿ ಇನ್ನೊಂದು ವಿಚಾರ ಏನಪ್ಪ ಅಂತಂದರೆ, we can treat a solid metallic sphere also as a spherical shell. ಯಾಕೆ ಸರ್ ಹಂಗಂತೀರ ಅಂತಂದರೆ, ಬಿಕಾಸ್ ಅಲ್ಲೂ ಅಷ್ಟೇ ಒಳಗಡೆ ನಮಗೆ ಚಾರ್ಜಸ್ ಉಳಿಕೊಳ್ಳಲ್ಲ. ಸೊ ಇಫ್ ಇಟ್ ಈಸ್ ಎ ಕಂಡಕ್ಟರ್, ಎ ಸಾಲಿಡ್ ಸ್ಪೆರಿಕಲ್ ಶೆಲ್ ಆರ್ ಎ ಹ್ಯಾಲೋ ಸ್ಪೆರಿಕಲ್ ಶೆಲ್ ಬೋತ್ ಆರ್ ಸೇಮ್. ಓಕೆ, ಸೊ ಇದ್ರ ಸುತ್ತ ನಾವೇನು ಮಾಡಬೇಕೀಗ, ವಿ ಹ್ಯಾವ್ ಟು ಡ್ರಾ ಅ ಗಾಷಿಯನ್ ಸರ್ಫೇಸ್. ಇದೊಂದು ಗಾಷಿಯನ್ ಸರ್ಫೇಸ್ which is having a radius small r. At this point, we have to find the electric field. E point hatra electric field idಬೇಕು. As usual, ನಾನು ಇಲ್ಲಿ electric field calculate ಮಾಡಬೇಕಂದ್ರೆ I have to place +1 coulomb charge. +1 coulomb charge ಇಟ್ಟಾಗ due to this and positive, it will be repelled in this direction. Therefore, electric field ಈ direction ಇದೆ. And ಈ ರೀಜನ್ ಅಷ್ಟೇ ನಾವು ತಗೊಂಡಾಗ, ಓಕೆ, ಓನ್ಲಿ ದಿಸ್ ರೀಜನ್ ಇಫ್ ಐ ಕನ್ಸಿಡರ್, ಈ ರೀಜನಲ್ಲಿ ನಮಗೇನಾಗ್ತಾ ಇದೆ, ದ ಏರಿಯಲ್ ವೆಕ್ಟರ್ ಈಸ್ ಆಲ್ಸೋ ಇನ್ ಸೇಮ್ ಡೈರೆಕ್ಷನ್ ಡೆಲ್ಟಾ ಎಸ್. ಓಕೆ, ಸಿನ್ಸ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಆ್ಯಂಡ್ ದ ಏರಿಯಲ್ ವೆಕ್ಟರ್ ಬೋತ್ ಆರ್ ಇನ್ ಸೇಮ್ ಡೈರೆಕ್ಷನ್. ಅಕಾರ್ಡಿಂಗ್ ಟು Gauss theorem ಏನು ಹೇಳುತ್ತಾ, ದ ಟೋಟಲ್ ಫ್ಲಕ್ಸ್ ಎನ್ಕ್ಲೋಸ್ಡ್ ಬೈ ದ Gaussian surface. Okay, the total flux enclosed by the Gaussian surface is equal to Q by epsilon naught. Therefore, flux phi is equal to Q by epsilon naught, where total charge in this is Q anta assume ಮಾಡ್ಕೊಳ್ಳೋಣ. And flux phi is equal to summation of vector E dot vector ds. That is nothing but summation of E ds cos theta. Since ds and E are in both same direction, okay, phi is equal to E summation of ds. Since theta is equal to 0 degrees, cos theta is equal to 1. Therefore, flux phi is equal to E into ds. Therefore, E summation of ds ada, since it is summation of ds andre it is nothing but total distance. So first case we have to do for outside the surface. Okay, first case en ಮಾಡುವ, ಇದಕ್ಕೇನೆ we will put outside the surface. Okay, so outside the surface ಬರೋಷ್ಟೊತ್ತಿಗೆ the distance is becoming small r, and therefore the surface area summation of ds will become 4 pi r. Okay, therefore flux E into 4 pi r is equal to Q divided by epsilon naught. Therefore electric field E is equal to 1 divided by 4 pi epsilon, 4 pi r square, surface area, 4 pi r square into 1 by 4 pi epsilon naught, 1 divided by 4 pi epsilon naught Q divided by r square. Which is same as a point charge. Okay. So if I want to write this in a vector form, vector E is equal to 1 by 4 pi epsilon naught Q divided by r square into r cap. Okay. So this is the electric field outside. Next, if I consider another case, field on the surface. Okay, if I consider a case, field on the surface, R is equal to capital R. Therefore, electric field E is equal to 1 by 4 pi epsilon naught Q divided by capital R square into R cap. If we have done for on the surface and we have done in at some point outside the surface. Now if I consider case 3, inside the surface, then ಅವಾಗ ಏನಾಗ್ಬೋದು ನನಗೆ, see if I consider inside ಅಂದರೆ ಒಳಗಡೆ ನಾನು ಏನಾದರೂ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ, this is our sphere which is having plus charge on the top of it. ಹೌದಾ, ಹೊರಗಡೆ ನನಗೇನಿದೆ, we have a plus charge. ಈಗ ನಾನು ಒಳಗಡೆ ಅಷ್ಟೇ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಒಳಗಡೆ ಅಷ್ಟೇ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ, okay, the total charge enclosed by this Q is equal to how much? 0. ಯಾವ ಚಾರ್ಜ್ ಇಲ್ಲ ಒಳಗಡೆ. Therefore, electric field will be equal to 0. ಯಾಕೆ electric field 0 ಇದೆ ಅಂದರೆ, the main reason, one reason ಅಂದರೆ, when we drop a Gaussian surface inside a sphere, there is no charge enclosed by it, therefore it is 0. So, ಅಂದರೆ ಈಗ ನಾನು electric field versus distance ಅಂತ ಒಂದು ಕರ್ವ್ ಹಾಕ್ಕೊಂಡ್ರೆ ನಾವು, say for example, from 0, this is electric field versus distance. Okay, ಹಾಕ್ಕೊಂಡ್ರೆ initially it is 0, ಇಲ್ಲಿ ಏನು ಇರಲ್ಲ, electric field ಎಲ್ಲಿವರೆಗೂ ಇರಲ್ಲ, unless and until it comes to a position R ಬರೋವರೆಗೂ there is no field. Once it comes to R, the field is maximum. After that, if you see, electric field is inversely proportional to R square, which generates us a parabola. Okay, so inside ಏನು ಇರಲ್ಲ, outside ಇರ್ತದೆ. This is also true for a solid metallic sphere. ಒಂದು ಸಾಲಿಡ್ ಮೆಟಾಲಿಕ್ ಸ್ಪಿಯರ್ ತಗೊಂಡು, ಶೆಲ್ ಬದಲು ಒಂದು ಸಾಲಿಡ್ ಮೆಟಾಲಿಕ್ ಸ್ಪಿಯರ್ ತಗೊಂಡ್ರು ಕೂಡ, the things are remains same. I hope you understood this one. Thank you.